This is the Tasco scope as set up for viewing. It's 114mm focal length, 900mm, and I've set it up on the Polestar rough polar alignment. And what we're looking at tonight is up there in the sky, it's the Gibbous moon. And basically all I'm doing is holding my video camera, which is what I'm holding now, not right up to the lens, about a good 2 inches away, and then focusing into the camera using the camera's focuses. You can see there's the focuses there. So holding the camera fairly steady myself, only handheld, and looking at the moon that way. It's one way of getting a quick few shots to check the quality of your telescope. Looking down the tube of my Tasco telescope, the 3012, you'll see at the bottom is a fully coated 114mm diameter parabolic mirror, and this is the secondary mirror here. Light comes from the distant stars, hits the parabolic mirror, comes back up to the secondary, and the mirror then reflects the light out to this tube here, into the tube, and then up to the eyepiece here. Now your eyepiece should be set bang on so that when you look down the telescope it should line up right with this finder, so that I can see right in the middle, if I get the angle correct, right in the middle of the mirror. The actual finder should be right in the middle of the mirror, the actual position of it. Some people put little dots on their mirror. I haven't, but some people do put little dots on their mirror, and there are ways in which you can adjust it, and usually it's with using these little screws here which you can use Allen keys. You've got to be careful, you don't want this to fall onto your primary. If you have to make any adjustments, make sure you put a cloth over your primary mirror, so in case anything falls down it doesn't scratch your primary mirror. That's a top tip from me. The Tasco 3020 came with instructions of what parts make up the equatorial mount, and also you got a 10mm eyepiece, a 4mm eyepiece, and a moon filter. Never ever look at the sun using your telescope unless you follow instructions to project it onto a card, and in which case you need to have what's known as solar projection. You shouldn't look at it using your eyes. There is a special sidereal chart that comes with the Tasco telescope, the 140mm telescope, which I'm using. Now what you do is you look up the day and month. At the moment when I'm talking to you it's December the 29th, and if it was 8 PM where you are, then the sidereal time would be 2:33 on a 24-hour clock. Okay, so at the moment the time where I am now is 4:30, which is 3.5 hours earlier. So I have to knock off 3.5 hours off that time there. 2.5 hours would bring it back to zero, if you like, and then I've got to knock off another hour off that. So that then takes it to 2300 hours. If I want to use my telescope mount in order to take some pictures using a camera instead of just the telescope, what I need to do is use a sidereal chart, as I've got here on the table. I look up the date using my sidereal chart. It's the 4th of January. It tells me that at 8 PM this evening it was 2:57 in sidereal time. When I look at my clock now, it's just coming up to 7 o'clock, so that means it's 1:57. Maybe a little bit before, a few minutes before, and I have to knock off 5 minutes so my clock's a bit fast, so call it 1:52. So when I go out to my telescope and I put this camera, I can put it on the piggyback mount. You'll see that the camera has got a little recess here which has got a thread inside it. This is how you work out sidereal time, and this is why it happens. If we're looking down on the Earth, and you assume here that you've got some person here stood on the Earth, and as the Earth is rotating around, this light area here is daytime because the sun's rays are reaching the Earth, and this Earth is considered to be rotating anti-clockwise. This area of the Earth is in shadow or nighttime. Okay, if you consider someone standing at this point here and it's noon, then the Earth will rotate 360 degrees. That's one rotation. And if it was staying in the same place in space, it would always be the case that this person would see that sun there at the same time every day. However, that isn't true, because the Earth has an orbit which goes around the sun. If you take the Earth rotating once, by the time it's gone round once, it's also had to move along here in this orbit. So the person stood where they were there, although they've gone round 360 degrees, they've had to also move along the orbit, so they are no longer pointing up where they look up in the sky, at the same place in the sky as they were the day before. The difference in time between them, in other words, the difference in time it takes that person to point at the same place in the sky as they were the day before, is the difference between a solar day and a sidereal day. And astronomers have worked this out to be 3 minutes 56.556 seconds if you go down and have a look at the chart difference. So the difference means, because it's a faster, sidereal days are faster than solar days, it means that in a year there are 366.25 sidereal or star days, but only 365.25 solar days in a year. Now, astronomers will always prefer to use sidereal time rather than solar time, for the pure purposes they're interested in distant space and looking at objects which are considerable distances away. And of course, the Earth doesn't move in a circle around the Sun, it moves in an ellipse, which further complicates matters. But your telescope is set for sidereal time, so basically this means on this particular day here, when you are here, if you were able to see into space, you would notice that the next day you would not be in exactly the same looking at the same space. It would have moved with respect to the previous day, and that movement is why you need the telescope to tell you what the sidereal time is. Once you've set your sidereal time, remember the clock is carrying on ticking, so you're going to have to change it as you observe. So that's what you have to do. The next thing you have to do is find the pole star. Now, if you go down to the mount, I've chosen and set up my tripod here on this Tasco basic telescope. It's not the most rigid of mounts, but it is wooden and quite heavy. Make sure these screws are on finger tight here, and make sure that your tray here is as level as you can get it. You can use a spirit level or something round like a ping pong ball or something. Remember, these mounts are quite heavy, so you'll need help to carry them round. They are very heavy and not really waterproof either. The next thing I did is I made sure that this circle here, which shows 360 degrees, like a double protractor itself, I set it so that 0 here, the leading edge of this, and there is a clamp for this, as you can see round the back here, you can clamp that, like so. I've clamped it, okay, there. I've set it so that 0 is where I want my true north to be. So this leading leg here is the leg I want, the middle of this leg, this line that would run through the 0, to point exactly to where the pole star is, if I could take a line up to the pole star that went down to the ground. Stop. Once you're lucky enough to have a clear night, which here in the UK means you have to be very lucky, you go outside and you carry your mount out, and this is, as I said, is a heavy mount. You then, first thing you do is you look up in the sky, okay, and you need to find out where the pole star is, and imagine a line running down from the pole star to the ground. And you need to turn your mount roughly so that my leading leg, in this case on the tripod, the middle of the leg would line up with where I believe the pole star is, if a line came to the pole star down to the ground. And I've got my mount set up like this, and there's 2 clamps. One clamp here does this axis here, which is called your declination axis in the sky, okay, and I've got that one set at the moment to be 90, okay. Again, it depends on how precisely your mount is set. This one seems to be that the needle isn't exact, but I've got to try and make it so that I think this is lined up exact. Okay, so line it up to 90 in the middle of that needle. Okay, so there's your 90 there, you see, and I'll turn it around gently so it's on 90. Okay, clamp that. And of course I've set my sidereal time, as I told you earlier, If the time has moved on, so you probably need to move your clock on. I'd set it to just past 23, and time's moved on now by another 10 minutes. Each one of these little gradations is 10 minutes, so I'm going to have to move it. It was just there. I'm going to have to move it there to about there, okay? Because time's ticking on. Stop. Once you've roughly set your tripod up to where you believe the pole star is from looking into the sky at night, you're ready to put your telescope tube on. Now, these are quite heavy, and I always keep the lens caps on at first, okay? And all I do is I've made a mark here and here on the tube. Now these marks tell me places where I can set the tube so that it balances correctly. In my case, because of what I'm going to be using with the telescope, I'm going to be using this line here, okay? And I'll show you why. Now, it can help if you have two people to do this job. At the moment I'm going to do this on my own, because you don't want this to slip, okay? So if I hold the tube there, the actual clamp here on the other side, if you just go to the side here, you'll find it's quite wiggly. Make sure that it's completely unwiggled and it fits over the top. I'm holding the bottom of the tube. This is where the mirror is, where my hand is here, and I clamp that there, and holding underneath with one hand, get the clamp screw in, okay? And without worrying about exactly where the telescope is at first, get that screw slightly in, okay, and bring it so that it's finger tight. Don't over tighten it, but make sure it's tight enough to clamp the tube. Okay, so it's only finger tight at the moment. Right, now I've got to find where my line is, so unscrew that slightly, okay, and push your tube up, and I should be able to find that line that I made with my marker. I believe it's about there, okay, and then my line was just above where the tube was, and then clamp your scope, but not too tight, tight enough obviously to hold it. I'm doing it just slightly beyond what I would call finger tight, okay? Stop.
Lots of star charts are available. I like using one which has a circular shape to it. Basically what you're supposed to do is where it says south at the bottom here, you're supposed to put it overhead where south will actually face south, and then you will have the eastern horizon on your left and the western horizon on your right. So if you were to look at me where I am now, I'd get this star chart here and I'd lift it over my head so that I would have north right over my head as I'm looking up into the sky, okay? And as I said to you, the west would be to my right and east would be to my south, and I should be able to identify the names of the constellations. And you can see from the chart, I'm using a magnifying glass here, helps me to see a bit more clearly. You should look for the shapes in the sky. This is a very good way of starting out astronomy, much more useful than just looking through your telescope and not knowing what you're looking for. Also, if you see something in the sky that interests you constellation wise, you can look up its coordinates, then using your little camera, put it on your tripod mount and dial up the coordinates of that area of the sky and take a little picture and see if you can capture some of the stars in that constellation by using your sidereal time and your clock mechanism. Well, it's a right ascension. You don't have to have a motor, you just have to make sure you keep changing the hour of your right ascension and find what you're looking for. Of course, if you have your TASCO 302012 paperwork diagrams, you can learn all the names of the parts of your telescope. It gives you an actual guide there, so you can get the proper names of things. For instance, your declination circle I mentioned here, pointing to that, and here you've got your G, which is your hour axis scale or right ascension, and this what I'm pointing to here is where you set your axis for your latitude scale, which is how many degrees. In my case, I'm 52 degrees north. Now, to find out the sidereal time today, I'm into January. It's January the 3rd. So being January the 3rd, when it was 8 p.m, it was 2:53. So I'm now nearly 11 p.m, so I've got to add on just short of 3 hours onto that. So sidereal time where I am at the moment will be 5:53. But it's a little bit fast saying that because it's actually only 22:49, so I've got to knock 10 minutes off that. So instead of being 5:53, it'll be 5:43. So if I set that on my hour axis of my telescope, I've got the correct sidereal time for now, just for this moment, and I can then move my telescope around to find objects in the sky. Can't do much tonight because it's cloudy. If you do get astronomy books, always look for ones that got a decent moon map, and of course a moon chart does come with the Tasco 302012. This one here comes from an astronomy book of mine, and you can get an idea of the craters and the name.
Checking indoors that I've done this correctly, what you do is, with this clamped on, undo both of your clamps. This is your declination axis clamp here. Undo that clamp. Don't unscrew it totally, just undo it so it's loose. And the one behind it, bring the camera around, there's another one there. Okay, here. And this is your right ascension clamp here. Unscrew this one. Okay, right. And then if you stop. Now to see if you've done it right, what you should do, if you look at the telescope now, is here I am as if I'm lined up to the polar axis, okay, as I was earlier. Twist the telescope this way, which is anti-clockwise, like so, okay, on its axis, slowly, you can use two hands, like that, okay, until it's horizontal. And it should, if you've got the balance point right, slightly out, as you can see, there, this end's a bit heavier than that, and it should balance, okay, like that. So I'm going to have to move this tube slightly down back that way to balance it, okay. So unscrew this clamp here, not totally, just a little bit, okay, and I'm going to have to shimmy the tube down a bit. It can be awkward, more than one person doing it can help. I'm just showing you this now, just move it down now, clamp again. Okay, now it should balance a bit better. Okay, and as I go around here, I can move the telescope round quite comfortably, and it's moving well on a balance point. Stop. Similarly, when I've got the telescope set up like this, it shouldn't skew across to there. Once I started moving the telescope in the direction that the sky moves, if I imagine the pole star where I am in the UK would be up in the sky there, 52 degrees above the horizon, just over. Once I start moving the telescope along this axis, it shouldn't drift too much. At the moment you can see it's moving around, and you need to, don't just twist it around, move it around using both axes like so, and it should, of its own accord, hold its own. At the moment it seems as if the telescope, it's quite well balanced, like so. Obviously you're not going to have both clamps totally undone, okay, but what you want is to have the telescope itself not making you do more work. If it's balanced, it's easy to find objects in the sky. Okay, now it's almost holding its own here, so I've got this as near as damn balanced correctly, so this scope should be very easy to move around to find an object in the sky. Okay, at the moment probably slightly a bit too heavy on this side here, so I could move it a tiny fraction that way just to see if that helps it a bit, but not much. Let's have a look. Yeah, maybe that's a little bit better. Okay, and then remember, when you're moving an object, when you're tracking objects in the sky, it's not just moving on one axis. That's moving. This is an axis here. You can see there. That's a declination axis. The telescope tube can move like this. Okay, that's this axis here. Okay, and I've balanced it for that axis. It's quite well balanced there. Okay, but don't forget, if I clamp this axis here, right? So let's set that to 90. Is near damn it 90. I could clamp that axis. Telescope can still move about there's an axis, there's another axis, which is this axis here, okay, and that's this one here. Can you see? So the telescope can still move about this axis here. Now, the trouble with my dial here, which is my right extension dial, is it's moving at the same time as the telescope. That's not really a problem as long as you keep setting it correctly. And like I showed you before, the time I've set it is past 2300. It's about 2 divisions past, each one division representing 10 minutes. So I'd probably have to hold that with my hand. But as you can see, there's an axis there, and I can move the telescope here. I can't move it along the declination axis though, because I've clamped it, but that's showing you just moving along this hour axis, okay? I can swing it. Don't overswing it to hit a leg, okay? Just remember that's that axis there, okay? So this should stay still on yours. Mine obviously got a bit of a problem. Also, so in order to check that your counterbalance here, which is held by this clamp here, and your telescope are set correctly, what you should do is clamp this axis here, your declination axis, at 90 like I've done here. With your declination axis clamped here at 90, the telescope will still be free to move. So basically, if you hold it gently by the weight, right, if I get back I can show you what I mean, very gently hold it, don't bash it, hold it gently. What you want is to have it so that this rod here is horizontal with respect to the ground. Don't worry about the angle of the tube, we're talking about a horizontal. So as near as I can get it, okay, that should be horizontal to the ground, okay? Once this is horizontal to the ground, what you're looking for is seeing whether or not the tube actually balances with it horizontal to the ground. So what I should be able to do, if I get the tube here, okay, is it should be that it's balanced like that. If it's not balanced, it tends to skew over. In other words, if I have the tube here, okay, and it's not balanced, when I produce it to horizontal as well, the tube might continue rotating around this way or rotating around that way. If the tube, when it's horizontal, kept rotating around this way, okay, that means this side's too heavy, and you'd have to move the counterweight that way. If when I put this rod here horizontal, and the weight itself is moving down, okay, there's a moment that way, that means the weight is too far over that way, and you have to move the weight back, and you have to use it just using this clamp. Again, move things gently on the telescope. So that's one axis done with the declination axis clamped. So once that's steady, this is actually balanced, as you can see. Mine's balanced, so that's horizontal to the ground, relative to the ground, okay. That's horizontal there, I would say, looking by eye. And there shouldn't be any movement, okay. It should stay where it is. So that's one axis sorted out. Okay, once that's been done, rotate the telescope gently back. Of course, this axis here is clamped. This one's free to move, the hour axis or right center axis. Move it back to how you had it set, okay? So the telescope is pointing up to the pole star again on rough alignment there, so that's clamped at 90, okay? Now, what you need to do is clamp the hour axis, that's this one here, around the back, clamp this clamp here, okay, and unclamp your declination axis here, okay, so this one's free to move. Don't totally undo it, just unscrew it so it's loose. Now, here you have another test of the telescope. That is, if I move the telescope this way, does it carry on moving or does it stay still? Mine, as you can see, tends to stay still. That means it's balanced, okay, all on its own. This axis here being, this declination axis being free to move, the hour axis, this one here, okay, and you set the hour axis, of course, in between, that's your marker where you set your hour axis, okay, is clamped. So, if the tube was moving, and if I had the tube here and it just kept moving and tilting this way, that means what happens is this end of the tube is top heavy, okay, and you're going to have to gently undo this screw here, okay, and shimmy the tube down a bit using two hands. Okay, gentle movement until you've got what I've got, which is a balanced telescope. Okay, so there you go. That telescope is then easy to move around the heavens, and you can see and observe without too much strain in the dark. And this should be done inside your living room. Make a mark on the tube, use like a little pen or something like that, a little marker pen, and make a little mark on your tube. That tells you exactly how it lines. Of course, if you put anything else on your telescope, such as a different finder, I've got a different eyepiece. I put a zoom eyepiece on this one that came from a Bresser. The reason I put the zoom on is I've got this offers me a choice of magnifications without changing my eyepiece, and it's got plenty of eye relief on it, so I didn't use the telescope. This is what came with the Tasco telescope, and this is the instructions that came, the Tasco 302012. The Tasco 302012 114mm telescope also came with a lovely moon map called Rand McNally Moon Map. This is a fantastic moon map, and obviously the moon will fascinate you when you have got a telescope. And it's got, obviously this is the side facing the Earth, and then it's got a smaller map to the other side of the moon. Okay.